Practical Work Generic Skill Topic 3. My name is TARANI NAIDU B.RAMESH and my MATRIC number is 01DEE24F113. Today I'll be explaining Practical Work 3 on bipolar junction transistors, or also known as BJTs. First of all, what is BJT? A BJT is a semiconductor device used to amplify or switch electronic signals. It is significant because it plays a vital role in many electronic circuits such as amplifiers, switches, and signal modulators. BJT has three terminals, which is base, collector, and emitter. The base terminal regulates the current flow between collector and emitter. A small current entering the base controls a larger current flowing from collector to emitter. This is how BJT acts as amplifiers or switches. Next, we have collector terminal, where the current enters the transistor, and emitter terminal, where the current exits the transistor. The objective of this experiment is to investigate the terminals of BJT, to understand the types of BJTs, and to explore the materials used in BJTs. Firstly, before starting the experiment, plug the red probe at the negative COM output of the multimeter. Then plug the black probe at the positive output of multimeter. So, how to identify the base of BJT? Select the ohm range selector to times 10 ohm of the multimeter. Then, make sure to do the 0 ohm adjustment to get an accurate result. Second, name the three terminals of the transistor as terminal 1, terminal 2, and terminal 3. Thirdly, touch the red probe of the multimeter to the first terminal of transistor and touch the black probe to the second terminal of the transistor. The multimeter reading shows infinity. And without changing the red probe positioned at the first terminal, move the black probe from the second terminal to the third terminal and record the meter reading. The multimeter again shows an infinity reading. Now, change the first terminal to black probe and touch the red probe to the second terminal of the transistor. The multimeter shows 85 ohm resistance. Without changing the position of red probe, change the black probe from first terminal to the third terminal. The multimeter reading is 80 ohm resistance. Next, change the red probe to the third terminal and the black probe to the first terminal. The multimeter reading once again shows infinity. Lastly, without changing the red probe, change the black probe from the first terminal to the second terminal. The multimeter shows infinity reading. There was multimeter reading when we tested terminal 2 and 1 and terminal 2 and 3. Thus, it indicates that the terminal 2 of the transistor is the base. Now, let's see how to identify collector and emitter. First, switch the multimeter range to 10 times kilo ohm and do the 0 ohm adjustment. Then, put the black probe at the base second terminal and red probe at terminal 1. The multimeter reading shows infinity value. Without changing the black probe, change the red probe to the third terminal. The multimeter shows reading but slightly a lower value. The terminal that gives a lower resistance is the emitter, which leads the higher one is the collector. Thus, the first terminal is collector and the third terminal is emitter. Now, how to identify types of transistor, whether it is a PNP or NPN. But before that, let's see what's a PNP and NPN transistor. NPN transistor is when current flows from the collector to emitter. The base is positive with respect to emitter. However, PNP transistor is when current flows from the emitter to collector. The base is negative with respect to the emitter. What are the differences between them? NPN allows electron to flow. However, PNP uses holes. And in NPN, the transistor turns on when the base is more positive. There are also differences in the symbols of the NPN and PNP transistor, which in NPN transistor the arrow points out of the emitter. However, in PNP transistor the arrow points into the emitter. To identify the transistor, whether it is a PNP or NPN transistor, put the red probe on the base and the black probe at the first terminal or the third terminal. There is multimeter reading, thus the transistor is a NPN transistor. Other than that, how to identify the types of transistor, whether it is a silicon transistor or germanium transistor. What are silicon and germanium? Those are the semiconductor materials that are used to make BJTs. Silicon is most commonly used due to its stability and thermal performance. However, germanium is less used due to its low temperature tolerance and leakage current. Thus, silicon is a better option to make BJTs because it has high temperature resistance, low leakage current, and widely available and cost effective. To identify whether it is a silicon or germanium transistor, touch the red probe to the emitter terminal while the black probe to the collector terminal. The multimeter shows infinity reading. Now, change the red probe to the collector and black probe to the emitter. The multimeter again shows infinity reading. If both reading shows a high resistance reading, then the transistor is a silicon type transistor and vice versa if it's a germanium transistor. To sum up all, we've learned that BJTs have three terminals: base, collector and emitter. Moreover, there are two types of transistors, which is NPN and PNP. BJTs are mostly made using silicon due to better thermal and electrical properties. Understanding BJTs is significant for designing amplifiers, switches and many more other electronic circuits. That's all from me. Hope you enjoyed the video. Thank you for watching.